Okay, now that we have an idea of what row operations do for 2x2 matrices, let's go ahead and extend that same idea and all the same principles to 3x3 matrices. Now, if this is what an augmented matrix looks like for a 3x3 system of linear equations, then of course via the row operations, if we were to come out with the row echelon form of that augmented matrix, then it will look like this. Okay, now how are we going to go ahead and get it into that form? Well, there's some key steps in getting it into that form. First of all, again, we want to go ahead and first try to make A being equal to 1. If A is equal to 1, then we can go ahead and use our row operations to very simply make E, this element here, and this element I, to be equal to 0 using row operations. Then what we want to do is we want to make F being equal to 1. We want to make F being equal to 1. And then after that, by using that same idea, we want to go ahead and make J, which is right below F, to be equal to 0. And if we go about doing that, then we'll be able to come out with what is our row echelon form for an augmented 3x3 matrix. Okay, now so again, what is the advantage of this? Well, first of all, it's going to allow us again to analyze the system. Now before, when we took a look at this in the standard level course, we had no way of analyzing the system. Basically what we had was a means, by using the graphing calculator, to determine what the solution for a particular 3x3 matrix was. Now if, again, the matrix A was singular, then we were stuck. We didn't know exactly what was happening to the system at all. But now we can go ahead and analyze the system, and it will give us a very clear idea of what is happening in terms of its solutions, the number of solutions, or whether there is a solution at all. So one other thing is that if there is a unique solution, you can determine what it is without the graphic display calculator, because of course we can just go backwards step by step, because we can first find out what Z is, and then we can find out what Y is, and then we can find out what X is. Okay? So the process of getting it from getting a 3x3 augmented matrix into its row echelon form is a little more complicated, but the process is still very much the same. It's going to allow us to analyze the system again, and again, this time, if we can solve for a unique solution, we can do it without the graphing display calculator. Now, here's a question for you: what's the difference between REF, or row echelon form, and RREF, which is reduced row echelon form? And I'll leave that up to you to go ahead and look into the textbook to see what the difference is, and we'll go ahead and talk about those differences the next time that we meet. Okay? See you later. Bye-bye.